Hello. Welcome to any of my combo lords out there. Tonight we have a special stream for a few reasons, and I'm going to get a few things out of the way just to start that I'm sure a few people will ask me over the course of this stream. And when people inevitably ask me these things, me or the other chat people can tell them to refer to the beginning of this video where it'll all be explained. First of all, yes, it is quite dark because we are in our lantern mode in the tent again. It was the last chance with enough room out here in the combo classroom to set up a whole nice sized tent. I haven't gotten a small portable one yet, and this one takes up a bit of room. And have another night or two where I sleep out here under the stars with the bird sounds to wake me up. And second of all, yes, I have finished the haircut. I know half of the hair was cut in the last few streams, and now the hair has fully been cut. Now, the beard as well was shaved off with one of those buzzy type of razors. I don't know what you call those. I'm not a fashion guy, obviously. But those buzzy type of razors got the beard part of the area nicely matched up, so the other half has caught up. However, with the hair, I did trim that myself with scissors, mostly just without looking at anything while doing a scene. And so the hair may need a little trimming up and tidying up in the future. All of the details about these haircuts and such will be in the finale episode that I just finished filming, coming out on the main Combo Class channel toward the end of March, which is sometime next week. And that'll be somewhat around, possibly up to an hour, definitely at least half an hour, but not live stream style, very edited, of many little adventures and thoughts that I need to share. And I really hope that all of you watch that whole thing like it's a short movie, because it's a somewhat important documentary to me, and includes not only a lot of present fun adventures, but also a lot of wild past flashbacks of footage that you didn't know about and haven't seen. Now, as for the last thing that people are probably going to ask, I don't have a lab coat on wearing one right now. This layer looks somewhat lab coat-esque, but it's not actually a lab coat. However, that is not because I don't have any lab coats right now. It's actually because I have two lab coats right now. Yes, as I've said, there will be a transition to a cleaner, newer lab coat probably once per grade, and at least certainly at the beginning of grade -2. And as I film the rest of that finale episode that I'm now going into editing on, the lab coat, we'll get a small preview, has met its final days of the previous lab coat. And this has gone into relic status, where if I put this on not carefully enough, I'm going to destroy it pretty badly because it's all burnt. And we will see why it's relic status in that episode, and we will move on to the new lab coat. But I'm not going to get the new lab coat all camping style dirty quite yet because we haven't officially launched the grade. So we're in a rare week of between lab coats. Hello to everybody joining me there in the comments. Thank you for joining me. And I want to also note that apart from it being a good time to go camping, and I'm not sure if that's just my internet or if it's all coming through like this. Am I coming through all ghost-like and weird half the time? That's interesting. I think the camera's trying to focus on my face and having trouble with the light. Looks kind of interesting, though. Now, apart from having a good excuse to camp out here and some fun stuff to show you, I also have on this channel, we have just passed a cool amount of subscribers. I don't mean 110,000, I mean 110,880. That is more of a pure fundamental number outside of our base, arguably. Now, 110,000 does have some good traits due to ending with 4 zeros in our base. As I've gone into in an episode, if you end in zeros in one of the typical integer bases, you have certain aspects of divisibility, and divisibility by powers. In fact, if you end in 4 zeros in a base, you are divisible by a fourth power. And so numbers like that do have some fundamental aspects, but they're pretty base dependent when you look at a number like 110,000 or even 100,000 out of the blue. And these base dependent ones, if we weren't looking in our base, might not necessarily be the landmark numbers you'd pick as an example of a large number on a fundamental sense. Now, what would be a large number on a fundamental sense? Well, there's many ways we could analyze that. You could, at a certain scale, start looking for which numbers are prime, because prime numbers are, in a way, the building blocks in rare and fundamental. Those are, the numbers that their only way of dividing them, which is, in a way, the reverse of the highly composites we're going to look at. Primes are the least divisible that a whole number bigger than 1 can be. The number 1 is even less divisible. Its only factor is itself, which is 1, compared to a prime, which at least has 2 factors. And when I'm saying factors, as usual, we're just looking at the positive factors. And primes just have 2 factors in that case. And a little more divisible than 1, which is called the unit and not the prime, partially for that reason of it, when you define a prime as its only factors are 1 in itself, which is a common definition. 1 has 1 in itself being the same thing, so it's a little different. Also, that's not my favorite definition of prime. My preferred definition is numbers with 2 factors, or positive factors to be extra clear, because prime numbers always have exactly 2 factors. That's a lot clearer than going through the whole idea of, well, I got to explain that it's divisible by themselves in 1. 2 factors gives you all the details. There's an if and only if there. So the opposite of a prime would arguably be a very divisible number. And whoa, look at that wind. You see that wind? So it is a windy day out here. We'll take a peek outside the tent in a moment. See what it's looking like out there. And hello to everybody here. Remember not to spam comments, so I'm not more likely to look at it just because you leave it multiple times. In fact, I'm more likely to reply to the ones that are just left a singular thought and then a next thought. But thank you all for joining me. And what I was talking about primes for was that primes can be seen as the least divisible numbers apart from the unit when we're looking at whole positive numbers. And the opposite of that could be called the most divisible numbers. And you could argue that the most divisible numbers could be your good building block numbers, that if you're saying what's a big number fundamentally, that could be one. Another one that comes to my mind as a fundamental set of big numbers is the factorials, where you go like 8 factorials, 1 times 2 times 3 times 4 times up through times 8. And the factorials are a very fundamental set of building blocks. However, there's not as many factorials. And if we look at the factorials here, whoa, the wind is going crazy. And I hope my internet's not going really weird. I hope that's just on my end. If it is, should clear up soon. Sometimes my internet's just a little slow. Someone's mentioning the least common multiple versions of factorials, which is a good list. I love that list. I've thought that myself and looked it up on the OEIS, and we'll pull that up right now. In fact, on the OEIS, the list that was mentioned in the comments is a fun one, and it's the way I would define this is, for a given number, like for the number 4, what is the smallest number that's divisible by all of the whole numbers up to 4? Divisible by 1, divisible by 2, divisible by 3, divisible by 4. Well, that answer is 12, and that's the 4th term on this list because of that. So shrinking myself for a moment to look at the OEIS, this is the online encyclopedia of integer sequence is a very classic one. And if we look this up, we see that list, the least common multiple of 1 through n being the given term. And for example, 60 here appears twice because the smallest whole number that's divisible by 1, 2, 3, 4, or 5 is 60. Also, that's the smallest whole number divisible by 1, 2, 3, 4, 5, or 6, because 60 gets the divisible by 6 for free by having been divisible by 2 and 3 already. Then your least common multiple for the 7th, the smallest number divisible by 1, 2, 3, 4, 5, 6, and 7 is 420, which is obviously the reason why people talk about that a lot culturally. Clearly, whenever you hear 420 in a meme or something, they're referring to this fact that it's the 7th term on this pretty cool math list. That it's the smallest number divisible by 1, 2, 3, 4, 5, 6, or 7. Then you got some others, including one that will show up on our list here. In fact, some of these will. Let's take a look right here at 2520, 27720, 360, 360, 720, 720. Keep those in your head for a minute, because those for sure are going to show up a little later in this stream. Those are highly composite. Now, to get to what highly composites are real quick, because whether or not you know what they are something that can have technical definitions or can have casual ways of leading to them. So let's lead to them casually, and that can always give us a more fundamental, other deep sense of what they are and why they're sort of nicknamed anti-primes by some. So the nickname anti-prime fits these highly composites well. Not this sequence right here, which is also cool. Now, the factorials I mentioned, which are good building blocks, some of them show up on the highly composites list. When we get to the highly composites, the first 7 factorials will show up on there, and then no future factorials will. The first 7 get on there, though, with other highly composites between. Now, factorials are great big landmark numbers, no matter what base you count in, but they're few and far between. We're not going to hit one of those as a subscriber goal on this channel for a long time. Maybe the main combo class channel will get to 8 factorial subscribers before long. Make sure you're tuned on to the main combo class channel too. But apart from factorials, what these show up on a list of, the first 7 of these, is the highly composites. And highly composites, you could say, are the most divisible numbers for their size, because if I asked what's the most divisible number, there's no answer to that. I can always cook up a bigger number. I can even just say 2 to the power of 1 million is gonna have a lot of factors just by all of those 2's that multiplied into it, even though it's not going to be a record breaker for its size of total factors. It will be a record breaker compared to bigger, more factors than a bunch of smaller numbers than the ones in the range we're going to be looking at today. So you can never find the number with most factors. You can make a number with more factors, but you could find ways of saying what is the most factors for its size. In other words, which ones break the record if you were going up the number line and analyzing some traits about factorage. Which ones would win for the first time? Not that they could never be beaten in a given trait, but that they were the first to set a landmark. Now, if we looked at what had the most prime factors, where you break everything down to the smallest primes that make it up, it would be the powers of 2. Would be, for their size, have the most prime factors. Like 2 to the 5th power is 32. That has the most amount of prime factors for any of the first 32 numbers. Nothing before that as a whole number has more than 5 prime factors, because the powers of 2 tuck in the tiniest prime factors. However, 2 to the 5th power does not have more total factors than 30. So if you say we're not looking at prime factors, we're looking at all the factors. So what are all the total positive numbers here that can divide it? Well, it's actually a more interesting, it's tricky to analyze the patterns of, although there are many patterns, list, and is the highly composite numbers, the numbers that have more factors than any smaller whole number. I did make an episode about these, but we're going to cover new ground in this stream. But there is an episode about this on the main channel, one of the first episodes on there. Funny enough, that was about when my hair did look like this back then. But because it hadn't grown out yet, and it once again hasn't grown out yet. Now, I better have my phone onto the chat just to make sure that not only is our chat well behaved, but that also I am noticing any interesting comments. And I should also check if we've hit this latest highly composite number yet, because of course I will explain more about the highly composites in a moment, but I do want to just note that one of the ones on this list is the amount of subscribers we probably just hit like any second right now. So checking on that, let's see. Checking on, no ads. Okay, ads are good, but not right now. There. So, what we're going to do is first note that we just, as of any second now and right now, have just passed 110,880 combo lords on here, which is super awesome. And I'm going to brighten up the screen, so maybe that'll help see me a little bit more too, because I know it's super dark in our tent. We'll also look at what the night combo classroom looks like in a little bit. Now, here we have a highly composite number. The one we just passed has 144 factors, but since the previous one has 128 factors, that means that this 110880 number has the most amount of factors since that. It's the first record breaker, and it means that it's the smallest number with more than 129 factors, or more than 128 with 129 or more factors. It happens to have a good amount more. It has 144. It has 12 squared. The number called a gross was the historical nickname for 144. It has a gross amount of factors, but it also is the smallest number just in general with more than 128 factors. It is way more divisible than 100,000. In fact, I'm pretty sure it's more divisible than 1,000,000. Someone can double check me, but 1,000,000 I think is the number that has 100 factors. One of the Ilians has 100, and as many factors, meaning is as divisible as the normal 1,000. 1,000's not on the highly composite list. No, not as 10,000, nor as 1,000,000, because those are not very divisible numbers for their size. We're used to them because of our base, but they're not very divisible. And we can notice that some of these ones are better versions of those. Like instead of 10,000, you got 10,080. There's a better version of 1,000,000 too that we'll pull up on the OEIS here. Highly composite. And we're going to look at a longer list. They usually link a full list somewhere here. Well, I mean, not full. There's an infinite amount of them, but very long list. And here we can see that the 48th highly composite number is not much more than 1,000,000, and that is what I call the practical million, because it is a much more divisible million. And regardless of what base you count it in, that would be a divisible number. And 1,000,000 is only looking like an all-star because of our base. It's a pretty cool number due to being a perfect power, but it's not as cool as this number that is more divisible than any smaller number. 108, 108, 00. And look, it looks like that resolution, you know, from videos, 1080. That didn't quite make it on this list, although it's very divisible, but its clones did. Look, 10,080 made it on. 110880, the one we just passed, which is that, and then this next one, the one I called a practical million. Now, we get other clones on here as well. And here are the ones I noticed from that list earlier. There we go. That fella. That fella. But we do get some cool clones. Look, we got 720 and 360 on there. You know those numbers. We pick very divisible numbers on purpose for things like geometry. They show up in video resolutions. They show up in historical counting measures. They show up in clocks. So, look at this. 720, 720. We got a clone of 720 up there. This mutant double fella. 144, 1440. Check that out. You got, these look clone-like as well. And look, 360, 360, oh. So, and then with the zeros, 720, 7200. You get all of these, and then the 144, 14400 with another one. You get all these clones. Look at all these ones that are matches of each other with an extra 0. Now, why would that happen? Why would we get so many iterations of these? Let's look at 720, for example. We have 720, 720, 720, and 720, 720. Why would we have those clones? Well, you got to think about what it takes to make a clone. And I'm going to make some more episodes where highly composite numbers come up. And so I'm not going to give you the 100% run through of why every single clone emerges, but I will give you enough details to put it together, which is that what it takes to get from this later level of clone was adding a 0. 720, 720, got another 0 at the end. And what that tells me is that in the primes that make this up, then later when I added another 2 and another 5 as primes into its factorization, that was also super divisible. Making a prime factorization get an extra 2 and an extra 5 generates a 0 in our base. What about this first stage where 720 went to 720 twice? Well, I showed in a short once a pretty neat trick. And although this may be in an episode at some point in the future, I might as well show it because it's pretty neat. And what we have right here is a trick I showed in a short once. Pick any string of numbers we'll do the 3-digit ones. If I want to know, the 3-digit ones are the ones I did a trick for. If I take 321 and I want to copy that, by copy, I mean clone it twice. Make a number that looks like it twice in a row. Well, it turns out if I multiply it by these 3 primes in a row, I get it doubled. And because it just so happens that these 3 primes in a row multiplied together give me 1001. And the 1000 part makes that iterated over there. I mean, whatever number I input, like ABC times that, if those are the digits. ABC times 1000 sends that over there, and ABC times 1 sends them over there next to each other. So that iterates any 3-digit number. Similarly, if I wanted to copy something, and this is in our base only, other bases would have their own patterns. If I wanted to iterate something that was a 4-digit number, like I wanted to copy 4321, 4321, well, I would need to multiply it by an extra 0 in there. And I would need to see what makes that up if I'm going to multiply it by the shreds of that, and it's 73 times 137. Looks kind of neat and symmetrical, but it's not that easy to make a trick out of. Like to be like, take a 4-digit number, multiply it by 73, then 137, then wow, it copied it. That's a little less impressive because it's so arbitrary looking. But when I realized that 101 has the prime, 1001 has the prime factorization of these 3 small primes in a row, I realized, that makes a good trick. You can take any 3-digit string. We'll do 567 this time, or no, 657 times these 3 primes, which are 3 primes in a row. And in terms of prime in a rowness. And here we got 657, 657. We doubled it. So now let's look at what makes up the highly composites for primes. Well, these small ones here, like 24, you got like 2 cubed times 3. Now, the interesting thing about these highly composites is that they don't build super linearly in terms of prime factors, making it sort of harder to guess what the next one would be just by looking at the list. Here you got 24 is more factors than anything smaller by being 2 cubed times 3, but you don't just add on a prime factor to get the next one. 36 is more divisible than that and anything smaller than itself, and that isn't 2 cubed times anything, it's only 2 squared times 3, this time squared. And we could tell, we lost a 2, gained a 3, that makes this 3/2 as big. It's true, this is 3/2 as big as that, but we can't see as linear of a pattern. In terms of how many 2's are in the prime factorization of each, it's like 3, 2, 4, 2, 3, 2, 4, 3, 4, 3, 2, 4, 3. It's harder to predict. And similarly with when we add something at the end. Here we have like, okay, I got my 3-evens. I'm doubly 3-even. Okay, singly 3-even. Oh, but now I'm adding some 5's in the mix. Now I'm doubly 3-even with the 5. Oh, singly 3-even with the 5. Okay, doubly 3-even with the 5's and singly 3-even with the 5 and a 7. All right, let's get some more 3's and keep the 7 back and forth and back. And oop, we're going to get an 11 in the mix just for a bit. Lose the 11 for a bit. 11 came back. So these are a little weirder. Now, there's a more linear pattern to the ones that have a star next to them, but we'll explain those in a minute. So the highly composites in general are a little harder to track, but we can see that they in general have a decent amount of 2's, then some amount of 3's for the size, a little less of those, a little less of those. They in general have a staircase-like prime factorization going downward, where they have more amount of the smaller primes in the prime factorization, not in as linear of a way as you might guess, like we get an 11 then lose it, but to a degree we can note that they're heavier on the primes to the front end of them. Now, when we look at how we said times 7 times 11 times 13 doubles something, well, we just so happen to get lucky enough that where 720 right there is 2 to the 4th power times 3 squared times 5. Well, we said if we multiply that by 7 times 11 times 13, we're going to double it. And it's true that 720, 720, if I look at the prime factorization of that, we get 2 to the 4th times 3 squared times 5 with that 7, 11, and 13 on top of it. And it is more divisible than any number between 1 and 720,719. It happens to get on this list as well. In fact, there it is, right at the end before Wikipedia cut it off. Now, we even got that with a 0 after, meaning that this, with an extra 2 in the mix, and one more 5 in the mix as well, is also highly composite, because we saw 720, 7200 on this one down here. So kind of fun how we get these clone ones on there. And what I would like to hear from any of you, if you ever know, is what patterns happen in other bases as for when you would get lookalikes, either in terms of a copy that adds a 0, or even more interestingly, a copy that doubles something in some way, when you get clones in other bases. Now, one funny thing we will go to for a moment as a note is that when we talk about highly composite numbers, we got to remember, when you hear a term in math that's like highly composite, you usually assume it's a subset of composite. But sometimes math terms are funny like that, where highly composite, which actually highly composite and superior highly composite numbers, some of the original research on a lot of their patterns was done by the great Indian mathematician Ramanujan, who is one of my favorite mathematicians. He did a lot of cool creative thinking and discovered a lot of interesting things. And he has some papers we'll look at sometimes, some cool written down by hand papers about highly composite patterns, and these ones that have the stars here that we'll talk about in a bit. Now, as for what I wanted to know briefly is we assume highly composites would all be composite. Sorry to say, there are two highly composite numbers that are not composite. One is, we said, the unit, and two is a prime. Yet they are on the highly composite list because they have more factors than any smaller positive integer. One beats the record just by starting it. It's just like on the list just by being the only one at the time. If we scan the first number, it's the only one to give the record to. I could imagine some definitions you could define highly composites as if you had given them a slightly alternate definition, because they're fundamental enough that you could, define them differently and you would still come to them. Some ways of getting to highly composite numbers might end up with one not being on the list, but it is typically considered one, a highly composite number. And two would pretty much always, no matter how you define it, have to be considered highly composite because it has more factors than one. It has two factors as opposed to one factor. So it's funny that sometimes you get highly composites that aren't composite, but that's not where these funny term overlaps end. Let me see if they have this thing here. Table of divisors. Check this out. The number 1 is... Okay, no, look at the number 2. Look at this. Number 2 is prime, meaning it's not composite, yet it's highly composite and superior highly composite. Now, abundant numbers are the opposite of deficient numbers, with in between being perfect numbers. So every whole number is either abundant, deficient, or perfect. It means does your factors apart from yourself add up to less than you, equal to you, or more than you? Well, deficient here could be written as not abundant or perfect, saying that not abundant or perfect is synonymous with deficient here. So 2 is not abundant, but it's highly abundant. Like how it's not composite, but it's highly composite. Highly abundant numbers are another way of defining high divisibility. There are even colossally abundant numbers and other terms for super. There's one, I was going to say other terms for superabundant numbers, but there literally is one called superabundant numbers. So I can't even use that casually and be like superabundant. Superabundant's another type. So there's a lot of ways of defining most divisible, but my favorite has got to just be straight up highly composite because it's just so natural. It wins the race for the size in terms of all the factors. Does it have more factors than anything smaller? Now, some of these others you could see have slightly more technical definitions, such as the one we're going to get to in a minute, which is the ones with the stars are the ones called superior highly composite, the stars on this list. So, of highly composites. So 2 has a star, 6, 12. These are the superior highly composites. And let's look at the first one of the ones of these. You got 2, and let's look how notable these are. 2, the start of base systems, typical modular systems, and things like that. A lot of things start at 2, the base of binary. 2 is obviously fundamental. 6, so underrated. I've been talking so much in my streams about how 6 is underrated, and I'm still going to make an episode once I track down that fact about 6 and 36's link that I mentioned in the other stream. I'm going to make more episodes about how glorious 6 is and why we should switch to base 6 and how the number 6 is really underrated. But we can see its underratedness straight up on this list. All of these other numbers are like the important numbers we use in society. It's like binary, clocks, clocks, this historical one called the long hundred, geometry degrees, when you use degrees in that. All of these are like these classic cultural ones, and snuck in there is 6 that doesn't get its credit. So 6 is on there. I love 6. 12 is classic. It's on there. 60, classic. Long 100, classic. 360, classic. This one is pretty underrated too. This one was on that list of the numbers that were the smallest number divisible by like 1 through n, like how what was it, we had that list here, yeah, like how 420 is the smallest number divisible by all the integers 1 through 7. This is the smallest number divisible by all the integers 1 through 9 and also 1 through 10. So whether you ask 1 through 9 or 1 through 10, that's the answer, 2520. Double it and you get this. I love this one too. 5040, a classic number. The philosopher Plato mentioned he thought it would be a good amount of people for a city. And that's probably because he knew it was super divisible. He either knew it was highly composite and or knew that it was a factorial. This is the largest factorial that's also highly composite, is 5040. Classic number. We're going to look at some facts of these numbers. We'll keep this list up. There's not a coincidence that all of these on the superior highly composites list have articles. These are blue. You see, like when we're back here, it's like when you get to this size, not many of these have their own article. But on the superiors, they didn't give them their article because they're a superior highly composite. They gave them their own article because they're really notable numbers. Wait, does this actually have its own article? Okay. That didn't have its own article, but as a mention in an article. We're going to look through and see which ones get a full article. This one, they note that it's that, as well as the colossally abundant. And it's on that list as well, where it's smallest number divisible by everything 1 through 16. So they do mention that other trait we were talking about. So that one's pretty cool number. And does this one have its own article? Nope. This one is mentioning those traits. And this one's going to have its own article. So we're going to look at that in a minute. And here we can see something notable about these. They build a bit more linearly. Look, 2. Keep the 2 and add a 3. Add another 2. Keep all that and add a 5. Add another 2. Now, the thing about these is that the actual definition of superior highly composites is part of why I didn't make an episode about them yet, because it's not that catchy of a definition. Although they're really cool numbers, the definition's a little harder to digest. It's that there exists this little number that they're using epsilon for. There is some number that where this inequality holds. And I'll go into the definition more. They have some examples there when I do an episode, but the reason now I know I definitely will do an episode about these before long in grade -2 is that when I was looking and studying facts about how these primes stack up in a much more consecutive building on the last one sort of way than the regular highly composites, which these are a subset of the highly composites that we're seeing this more linear pattern on almost, where whatever the last one has, it seems to keep it and add one new thing. And we can see because of that, they also are linear in number of prime factors. There's one superior highly composite with 1 prime factor. There's one with 2, one with 3, one with 4, etc. And so when you list them, you're interestingly not only listing this is the number of term, you're also listing this is how many prime factors it has. And so with these, when I was studying how they build more, I did find some catchy ways that I think I can explain them in a much more digestible way than this definition. We'll explain the definition, but there's a much catchier hook and explanation that I figured out how I could do that will be good to give superior highly composites, less in terms of this definition, more in terms of this prime factorization growing stack. So thank you to whoever is joining. Let me answer a few comments before we continue looking at our highly composites and some fun facts about some of these numbers. So, sorry if the internet has gone weird once in a while. That will inevitably happen. I don't know if it's going to be much worse because I'm outdoors in my tent. Could be. Maybe I should leave the tent unzipped. Now, thank you to the nice comments and to whoever's asking if this is a math class. To a degree, we are talking about highly composite numbers today, but we have done a good amount of the math stuff, and while I do have a few more math things to share, we're also going to be chatting about camping and chatting about the upcoming grade -2 and about things like that, because we are camping outdoors in a tent tonight as well. I decided that there was just enough time for one more weekend of sleeping out here with the birds. And whoever hates math, maybe stick around and get tricked into liking it, one fun fact at a time. Whether or not you like math, maybe we can just call it numbers. So, thank you all for the comments and such. What we're going to look at now is just a few fun facts about these two highly composites and maybe some of the smaller, probably the long 100 as well. These are some really underrated numbers, and some of them are even going to get credit for their whole episode. I think that at some point on the main combo class channel, there will be a whole episode about the number 6, and at some other point, there will be a whole episode about the number 120, the long 100. And I already used 12 to a degree in the highly composite episode I made on that channel way at the beginning of the grade. Feels like years ago, but I filmed it, about 1 year ago, or slightly over 1 year ago. I put it out less than a year ago. Feels like a while ago, but that was the last time my hair looked like this, I guess. And the highly composites there, I use 12 as an example. 12 is a classic. Like I said there, it gets a nickname, dozen. And not that many numbers get a nickname in addition to their normal one. It also gets less syllables in its normal name than the others. 12. Way quicker than 11, 13. So we also got the long 100. We need to bring that term back. Super underrated number and term. It used to even be called the 100 in many contexts. Then historically, to clarify, they started being like, okay, long 100 versus the new one we're calling the 100. So I don't think we're going to get back to calling this 100 as a society, but let's start saying long 100. Remember, not quite as important as the word threeven, which let's note that all superior highly composite numbers after the first one are threeven. All of them are even, and all of them after the first one are threeven. Every single one. Even on the normal highly composites, after you get past 1, 2, and 4, even though they don't build as linearly, every future one is going to be threeven after this point. So, our base, the base 10 system we're in, 1 million, not threeven. 1 billion, not threeven. 1 trillion, not threeven. But here on our logical list of a more fundamental type of large number, the big ones on here, we note they're threeven. And they become threeven much quicker than they become multiples of 5. Our base is good at handling multiples of 5, not good at handling multiples of 3, which means our base is okay at handling these ones up here, but it can't even digest the 3 part about it. And our base is bad straight up at handling any of these ones down here, like 6, 12, 24, 36, 48. These are fundamental numbers. All the divisible numbers, like in one of the most common ranges we deal with of number, and our base is bad at dividing by them and relatively bad at multiplying by them because it doesn't like the threevenness. So remember, threeven's very important. The reason I got on that sidetrack was to note that If you're throwing in threeven already, the next word to try and incorporate into your vocabulary could be long hundred. Now, funny enough, 360, I do give it much credit. However, when I discuss its credit, I don't want to give too much credit to the fact that degrees are split into 360, because that's a somewhat arbitrary choice, and I actually think radians, which are another way of measuring, are a bit neater. So 360's alright, but radians are in a way better. I will use degrees often because I want my content to be digestible, and a lot of people were taught that. But we will also do radians at times. So 360's coolest trait is not that we happened to cut a circle in it. We did cut the circle in it because of some of its coolest traits, though. Now, what about these fellas? This number that they're going to mention that Plato mentioned. Also, here is this thing called a Brown number. Actually, I believe nicknamed by Clifford Pickover, an author I really like. So if we see that Brown number, yep, we're named by Clifford Pickover. And although I believe named after someone named Brown. Yeah, after Kevin S. Brown. And what those are squares that are one more than a factorial. And these are the only three we know as a human species. And it's likely there are no others, not known though. So, gotta love your simple open questions. That's a simple open question in math. And number theory is full of those simple open questions about numbers. So here's another is, are there any other square numbers one larger than a factorial? There are an infinite amount of square numbers, infinite amount of factorials, but since they get spread out enough, sometimes the rate things get spread out, you can predict they might not bump paths again. And they say that there are none up to 1 quadrillion, and that Paul Erdős, which is a great mathematician, love this guy, classic in terms of open questions and puzzles. He would put bounties on questions. He would be like, I'll give $100 to whoever solves this question I want to know the answer to. If I ever had a bunch of money for whatever reason, I would totally do that. Put bounties on math problems, get people to solve some cool stuff. And so, if he predicted that is a decent resource or a decent citation or person to trust their gut feeling on, because he knows a lot about open questions. But that's something neat, is that 7 factorial might be the largest factorial that's one under a square. And it's also, it is definitely, you can prove, the largest factorial that is highly composite. Now, this is factorials. I wanted I wanted 5040. So we got this stuff about Plato mentioning it in Laws. And we also can note, they put its interesting notes down here for some reason. They note this thing about it's the largest factorial that's highly composite. And it has exactly 60 divisors. So that's a neat one, because 60 was also on our list. 5040 has 60 divisors. Those are the same as our factors. And random fact about it being the sum of some primes. Now, this is a super cool one. I'm not going to be able to explain this in the stream. I will at some point try and go into this. Y'all heard about the Riemann hypothesis. This is another one that we will be having an episode about in grade -2. It is a $1 million question. You literally get $1 million if you answer it thoroughly enough. Literally, you get $1 million. But anybody who does answer it will not be doing it for the money. Anyone who commits enough time and effort to actually crack this thing someday is going to be in love with math more than they're in love with money. And here they note that 5040 is the largest of 27 known numbers for which this inequality holds. And they mention something about how this inequality won't hold for any larger number than 5040 if and only if the Riemann hypothesis is true. Meaning somehow this could be a roundabout. This isn't going to be the way that's going to crack it, most likely. Very long shot. But there are some roundabout ways where if you proved some other thing, you would know whether or not this was true, the Riemann hypothesis. Now, if you actually prove the Riemann hypothesis itself thoroughly, you will be well known in the math world for sure, and you will get $1 million. So we're going to do an episode about that sometime, because it is probably the only one of those $1 million problems, which there are 7 of, one of which has been solved so far, that I know how to explain well enough to make a video about currently. Maybe the others I'll know well enough in the future to make videos, but this was the only one I currently know well enough. And it's a very cool, awesome problem. Very beautiful, relates to infinite series of numbers. But really it relates to a complicated, complex plane graph thing called an analytic continuation of the function on the complex plane and where its zeros are. But the function is a sort of infinite sum. And that's a cool one. So 5040 has a lot of good traits. They didn't actually mention that much about it right there. But let's check out this number that's half of it and look at all these traits it got. This means it's divisible by the sum of its digits. Look how many bases. 2 is the smallest base we'd describe that in, because base 1 does not follow the same rules and cannot be listed with what I would call the basic bases here. And so basically in all of the basic bases up through base 16, this is divisible by the sum of its digits. That's crazy. You write this in any base between 2 and 16, and in any of those, add up the digits, and you can divide this by that sum. It's also the smallest number that can divide anything from 1 to 10. Now it's half of 7 factorial because it was half of the other one, which also means if you cut the 1 times 2 off, you get half of it, which gives us this fact, that it's those 5 times. And you get some fun ones here about palindromics, all right, that's kind of cool, but rep digit, that's kind of cool. It's only 1 digit repeated in each of these bases. And here we got stuff about aliquot chains and sequences and trees, many nicknames for that. We have discussed those on the Combo Class channel once. Those are very fun. And a bunch of other types of super divisible thing. All of these numbers on this list have many awesome traits. The last one we'll have to look at for a moment is going to be the long 100, because that one's just so good. Now, like I said, we'll probably have to make a whole episode about it sometime, because it has a historical context as well, where it, 6 score, and it used to mean 100, but now it's stopped meaning 100. It's 120, and so it used to be more used because people didn't care as much about writing down the number in base 10. They cared more about how easy does this divide up packages and goods and foods and stuff. And this number is as divisible as 1,000, way more divisible than 100. So what is this? It's highly composite. It's 5 factorial. It is also a triangular number. It is also a tetrahedral number. It is the smallest number to appear 6 times in Pascal's triangle, due to being both triangular and tetrahedral. We'll see that connection later. It is also hexagonal. It is all of these types of highly composite stuff. It is a triperfect number because its factors add up to exactly 3 times it. Or in other words, its factors apart from itself add up to exactly twice it. That's the next level beyond what's called a perfect number, which is perfect numbers are super notable in number theory, and we seek them in math because they're connected to the largest primes ever discovered in a 1-to-1 correlation. If you find a new perfect number, you're gonna have found if you find the biggest, like a new perfect number that's bigger than any of the ones we know, you will have found also the largest prime number we know. They go hand in hand with the type called Mersenne primes that are the biggest ones we're currently finding. And so multi-perfect numbers or multiply perfect numbers or multi-perfect, and this type being order 3, nicknamed triperfect, are notable as well. And the cool thing about the triperfect ones, they think there might be only 6 of them, this being the smallest. They think that there's a chance that these are the only 6 numbers whose factors add up to exactly 3 times themselves. And 120 is the smallest of them. But it is an open question whether there are any others. Now, 120 is the sum of the twin prime pair that's hanging around outside 60. 120 has these other sums that it is. This one's kind of cool. The powers of 2 is kind of random because they started at 8 for the power of 2. However, powers of 3 is kind of neat here because if you don't include 3 to the 0th power, this does start from the first power. So it's like first power of 3, next, added up gets you 120. It's the sum of the first 4, you'd say non-zero powers of 3, but it doesn't mean the numbers that aren't 0, it means the powers that are the 0th power. So you could also call them non-1, because 1 is the number you get from the 0th power. 120 has other traits. It's so divisible, but it's also what's called an untouchable number, where no other numbers, proper divisors, meaning factors apart from themselves, add up to that number. So like we were saying, the factors apart from themselves of 120 added up to twice it. The factors apart from a perfect number add up to exactly itself. An untouchable number has no other number in existence has its proper divisors add up to the untouchable one. And look, 120 is, hey, it's the 6th one. 6 keeps coming up too. I love 6, and 120 seems to be friends with it. No surprise, they're both superior highly composite numbers, and they're both factorials and more, and triangular. Now, many more fun, cool ones here. We also note it's one of those brown number pairs, similar to 5040, because it's 1 under 11 squared. And more cool stuff. So, this is a funny one. 120 is the atomic number of unbenillium, an element yet to be discovered. It's like they know that there should be, based on what we know about elements, one that has an atomic number of 120, because atomic numbers line up with an actual physical trait of the thing. But we name the ones we haven't discovered these funny things because we don't know any traits about them, and they all get these names called like unquadquidium and stuff. This one's unbenillium or unbenallium or something. And it is a hypothetical element. There are other ones that used to have names like this that then got named relatively recently. And not that far from where I live, because I'm in the Bay Area of California, is the Lawrence Laboratories. And the Lawrence Laboratories discovered many elements. So there are many elements named after that. Lawrencium, Berkeleyum. There's a lot named after the Lawrence Laboratory there. And there's some that we haven't found yet, like unbenillium, however you pronounce that. Probably if you look up the pronunciation, it's like a pronunciation yet to be discovered. So there we go, 120. Amazing number. You can make it a tetrahedron, a triangle, or a factorial, or one less than a square, and all this other stuff. Pretty classic. So those are some facts about highly composite numbers, and the reason why I did all this stuff sort of as an intermediate check-in with our highly composites, because I already, almost a year ago dropped an episode first just explaining stuff about these, about which ones I think are the practical millions and such, and then at some point in grade -2, I'm going to do a more thorough dive into the superior highly composites and the structure that builds them with these prime factorizations. And we'll, explain this definition. But the reason why I did this intermediate one was somewhat because I was gonna do a subscriber special for 110,000, but that's a lame number in comparison to 110,880. Highly composite, and we have passed it. However, I like doing what I call the subscriber specials, half as a joke title on numbers. Is there any way we're back? Let's see. Maybe we have miraculously returned soon. And I think we've miraculously returned. So thank you for sticking around. Hopefully, even though it was at no percent and it just restarted from getting plugged in, the stream doesn't eat more power than it uses. Let me make myself large and not focus on any other clicking for a moment. Thank you for joining me, to whoever stuck around, and hopefully the stream processes right, or I'm not sure if it's going to have a long frozen section in the middle. So RIP to all the future viewers who have to watch that. Maybe I'll try and timestamp it like I try to when I have time. In any case, I'm glad that I didn't have to do a second stream, because sometimes all the streams popping up actually make some people unsubscribe. And it'd be quite ironic if I ended up doing like 5 different streams because I messed up the internet connection, charging everything, and then went below the highly composite number. But not to worry, I'm sure we're far enough past it. And thank you to all the people joining and saying hello. What we're going to take a look at momentarily is some of the nice surroundings out here, and maybe listen for some night wildlife. There used to be a lot more wildlife that would come around. There used to be possums, which possums are cool. And then there used to be raccoons. Raccoons are a little less cool. They mess with stuff. I mean, they're cool theoretically, but less I want them around. Then you get to your skunks, even less I want them around. So there's been a variety of critters that have popped in and around here. Right now, we haven't been getting many of those. We've been getting just our cats maybe have been running the zone and scaring those away or something. We still get plenty of squirrels. And I was thinking maybe I can leave some nuts out more often and attract those squirrel fellows who like to visit. And that could maybe bring more recurring squirrel visits. There's definitely a good amount of those in the finale I'm editing right now. So we'll make sure to get those squirrels returning a lot in grade -2. I think they've been returning more often now than they used to, so they must like the classroom. Maybe they think it's interesting, all the stuff we're teaching in there, and they want to join to learn some stuff. And let's see. And yeah, thank you all for the ones leaving good comments. Someone's saying baby skunks are good, and baby skunks are cute looking, but I don't necessarily want them around, because then the mom skunk will be even more protective. When you have a baby animal and the mom animal is around, it can get super protective. And like with bears, that's the most dangerous circumstance to meet a bear, is the mom with the kids around. It'll get very protective. And so I imagine skunks could be the same, where I don't want them to spray me. I have encountered many a skunk in the yard. None have sprayed me yet. So I'm hoping to avoid that. But when I've seen baby ones, it's more worrying, even though they're really cute. I do have videos of little ones. It's cute, but it's like, okay, where's the parents? If they're here, trust me, I'm not trying to mess with your baby. And so the skunks can be a little more problematic due to all the smells and everything they create. Raccoons also, I'm worried they'll mess with the cats, and they're just steal food, and they're really cocky and confident. You'll like run up to the raccoon clapping and yelling to get it away, and it'll just like stand there and be like, I guess I'll walk away. They are not scared of stuff. And when you go camping, often you have to avoid raccoon stuff. Right now, the type of camping I'm doing is just in the backyard, so I don't have any food right here. But I've had many raccoon experiences on camping trips too. When you go camping, you have to be careful where you lock your food. Some places you have your car nearby and you can lock your food in the car. Other places your car is not as close or accessible. You're hiked out somewhere, and you might have like a thing you can lock the food in if it's that type of site, or you might just be like out in the woods and need to figure out a way to not have bears and raccoons get your food. One of the classic techniques is to get it up in a tree, tie your stuff in bags, put a rope around it, swing it up around a tree and tie it so it's hanging. And techniques like that you're going to have to do. Sometimes put it somewhere surrounded by certain types of rocks that block it, or certain types of canister you can buy to hide stuff. But you got to find techniques such as getting it up in a tree to avoid those raccoons, because they will come up. And the ones that are near campsites, like especially campsites that are sites that many people use that the raccoons are used to, those raccoons know that they can get good meals there sometimes, and they will stalk you down all night trying to get that good meal. They will steal anything. I mean, watch your marshmallows. But raccoons are cool, but they do strange things. Out of all of them, somebody is mentioning of the possums, and the main type is more called possums, and those ones here are, I like the possums. They're quite cool. They play dead sometimes. One time my old cat I used to have a while ago went by on a fence. I need to find this video, which I do have from back in the day, and encountered one of the possums sitting on the fence, and it was out in the daytime, which they're not normally, and it was a younger baby one, and I hope it found its way home, but it was sitting there on the fence, and so it started just like freezing up and playing still and like trying to do its dead thing. I don't think it fully played dead, because when they do that they like emit a stench and like all this stuff, but it was like freezing up. And my cat was just like sniffing it, like, what do I do? What do I do? Do I eat this? This thing's way bigger than anything I've caught before. And eventually just stepped over it and kept walking, like, I don't know what to do with this. I'll leave it be. And they're really nice. They don't cause new problems. In fact, possums eat bad bugs and they help out. Then, there's other types of various wildlife, I imagine, but those are the biggest, most notable ones. But there are a lot of animals that do come out doing more night stuff. You can get little rats, you can get various types of little birds and stuff, various animals. Right now, I'm not sure how many we will see tonight. I didn't encounter too many on the other camping trips here. But maybe we will get some squirrels passing by, or maybe they're sleeping for the moment. And if we're really lucky, we will get my cat Dandelion or Sage or Sassafras, because they sometimes come in the tent. They didn't sleep in it back here in the classroom yet, but I've camped in the front yard and they've slept in the tent with me. And Dandelion checked out the tent back in the combo classroom once and was quite curious. And I will sometime set up one thing I got that I hope wasn't destroyed by the rain. At some point, I might get another one that I know works anyway. But something I might have a working one of, and if not, I'll get one at some point, is the type of camera that only films when it detects movement. So I really want to get those, like trail cameras or hunting cameras. I want to set one of those out so we can see the night wildlife that hides from people and just like goes by on its own. And we'll also have to comb through a lot of footage of falling leaves and stuff that the camera detects. But it gets nighttime stuff, so it'll get good nighttime stuff. But what it's built for is getting anything that moves. It'll save that bit of footage. So the ones that we want are when the animals move, although it'll catch some leaves and random stuff as well. Someone's saying some bat love and I should build a bat house. I don't know if bats live here commonly. I've never seen a bat here. So I think seen bats other places I've traveled, but I have not seen them here. I don't know, maybe they could live here, but I haven't seen the bats yet. So I'm going to be more focused in grade -2 on attracting birds and squirrels, because I know that birds and squirrels are around. And so we're going to be on missions to get as many bird and squirrel cameos as we can. And then maybe we'll try and attract weirder animals. You never know, because like I mentioned in my last stream, when me and one of my camera people were cleaning out the Convo classroom just the other day, and I'm probably going to put some footage of this in the finale. We were cleaning out a crazy corner of the Convo classroom that had all this old wood and stuff, and a corner that used to be flooded a little bit ago when the crazy rains hit. So when the rains hit, you may have seen sometimes it floods back here a bit and makes like a little river through the Convo class and miniature lakes. And it was doing that for a while. And then there was also a bunch of like wood and random stuff in that corner. It was making like a little marshland kind of. And when we were cleaning it up, we found 3 things that looked like worms at first, but they weren't. They had legs. And when I looked them up, I'm pretty sure they were salamanders. This type called a slender salamander. And I'm pretty sure that that's what they were. The camera guy, Carlo, brought them home to put in a slightly bigger habitat, and he might try and raise them. He put them in a bigger thing and was going to go look up what types of bugs and stuff you feed them and how to keep them happy. And they looked like these little pictures we saw of what's called slender salamanders. They were long and had these little legs coming out and were super cool. So I couldn't believe salamanders were in the Convo classroom. That was wild. But we will get more animal cameos as well from other stuff, because we're going to be taking more field trips. When I took a field trip the other day on my own for an episode that I'm making, we met a lot of cool types of bird, including large types of bird, larger birds than we'd see in the Convo classroom. And we will be going on more field trips in grade -2 to explore various wildlife, and I'm sure we'll encounter some cool animals on the way. And someone's mentioning a skink, and I haven't seen a skink in the classroom. That's another type of animal, and a lot of cool ones. Someone's saying they're lungless. I'm not sure if you mean those salamanders, but I read some stuff mildly like that. And to whoever asked me to please speak in Hindi, I only know English and the smallest amount of Spanish, not even enough to actually speak it. So I'm not far of a linguist. However, I have studied many word patterns and language patterns in English, so I know linguistics within that to a degree only. And yeah, the slender salamanders, I think I did remember reading something about their lunglessness when I was looking them up. That is interesting on all those traits different animals have, and amphibians are quite rare and unique. I'm a big fan of amphibians, and at some point we may see some sorts of frogs and stuff in the Convo classroom. I'm a big fan of various frogs and salamanders and newts and such. And so people were wondering what's going on to whoever is popping in, and we have transitioned from a few activities between a highly composite number learning section to a crashed section to now we will take a little peek around the Convo classroom. I'm going camping here tonight. I'm going to be sleeping right here, so like, you know, got my sleeping bag right there, and it is rocky on the ground. I am sleeping on a pad. Like, sometimes you want a camping pad to sleep on under you, and the degree to which that's necessary depends on the ground's firmness and bumpiness. And the combo classroom for sure has not only all those dice, but those are pretty flat in the ground, but it has like a bunch of markers and hourglasses and stuff sticking out of the dirt. And so I'm sleeping on that, but I do have a pad, so it was actually pretty comfortable the other night, surprisingly. Even though if we look at the dirt in a second, we'll see it's quite bumpy. Now, I am also under this on a tarp under the tent because it rained not that long ago, so it's super wet. So, as we emerge out here a little bit, we can see here is the entrance of my tent, and a little further here is what the dirt's like under the tarp. We can see that what I mean as far as the bumpiness is you got like dice and stuff just sticking down to the ground, as well as sticks and things. A lot of dice. Our dice carpet's doing quite well. And that's why I'm sleeping on a pad. But it's very nice here. And as we look over there, we see some other familiar things, such as the staghorn fern. And uh-oh, just got unplugged somehow. Bad. What's going on? We need this plugged. One second. Okay. There we go. Just got to make sure it does stay plugged in. Now, back here we got clocks and such. Now, if you look really closely, you probably don't have enough room to see. Maybe I'll shine a flashlight on my phone back there. You might be able to see some clues, because I have been filming the Rare Combo Class finale episode. Not the finale of the whole combo class, of course, but grade -1, which will be coming out next week on the main combo class channel. And there have been some upgrades and changes back there, and most of the upgrades aren't visible right there, because that is where I kept some of my good old classic clocks that we're keeping. But you might notice some minor differences if you're able to see any clues. I don't know what clues will be visible. Can't see much back there. Which is okay, because you're gonna have to wait mostly until next week to see that super rare episode, as well as our transition of many modular things like my haircut and like this, which is the lab coat you know and love. We will see all about that soon. It's been quite a month, and I am relieved to have shaved that hair, because I decided to cut off half the hair before the other hair for people who saw the last few live streams. So for the past like 2 weeks, I had half my hair really long and half really short, which looked to some people like just some fashion choice or something, which kind of annoyed me anyway, because I don't want people to be assuming I'm like going to some weird hipster barber and paying a bunch of money to get some weird, trying to be stylish haircut or something. So it's like, no, I just have half of it long and half of it short. It's for chaos time for a few weeks. But then when people would look at the beard, they'd be like, okay, whoa, there's just something off about this. Because half the beard looked pretty weird. And I shaved it. I knew I was going to do that at some point in this March. And I ended up committing a whole few weeks to it. And when I ended up doing it, it was like right before a bunch of social events and stuff. So I kept going out to like parties and things. And just people asking like, yo, dude, what's up with you? Are you all right? Like walking down the street, people just looking at me like, whoa. So remember, don't judge strangers or anyone by their appearances always, because a lot of people, when I've been walking down the street the last little bit, probably thought I was completely off my rocker, like didn't have a home or any sanity or anything. So while I am a little crazier than average, they probably had no idea that I was happily filming some crazy stuff and just wanted my beard like that for a few weeks. Don't always judge a book by its cover. And I did realize that the best line to tell people when I had half of the beard and they asked me like, hey man, how you doing? Was be like, oh, it's going 50-50, because we had like 50-50 on the face. Now, if you look at in the finale, while I have half of that and half of that, my goal was partially just as a strange interpretation of half cutting the beard in a extra mathematical half cutting way. But another reason for it was that I wanted it to look to a degree like the early season Domotro and the late season Domotro, early grade and late grade Domotro, kind of contrasting and appearing at the same time. And now we're more transitioned to the look of early grade Domotro. Even though it's the very end of grade -1, it is the very endest enough part that parts of me are looking like the early grade. We're getting ready. So we got the haircut that I'll probably need to tidy up because I did it myself without I cut a few more strands off in a mirror afterward, but all of the main part was just cut while I was being filmed, not looking at anything. So I'm sure it has some tidying up to do. But it did the trick. We got a couple fun weeks of experiment. I figured if you have long hair, why not for just at least a day cut off part of it in an absurd looking way just to see how it looks. Even just an hour. And then I decided on about 2 weeks. So, that is some fun stuff to look forward to. There's not going to be as much other new math content on this channel apart from the test answers this week, but that's just because I'm busy editing that whole documentary length episode. And the test answers will be fun videos too. I already released one part of those where I was going through about that final exam that I released for fun for grade -1 optional. Whether you did or didn't do it, you might want to check out the answer videos at some point after you've considered trying it yourself. And in those other parts of that, I'll go through more questions and not only go through the answer, but like in the first part, go through some problem-solving tips and tricks that you might use to solve it and how those might apply to other problems you might encounter. So that's all fun and good. Apart from that, it's always, hard to predict what type of content I will do on here, but I have been scheduling my Monday and Thursday streams, although I think it's likely that tomorrow there will either be a stream or bonus video. Small chance that I'll do a stream late enough tomorrow that I'll say that it has to be instead of my Monday morning one, because I've been doing a Monday morning one, but I don't know how many people actually are tuned into this specific time versus just watch it afterward. So I will see what comes up of tomorrow, but the reason I think there will be another stream or bonus video to talk about something is that even though we just did this as a subscriber special or whatever for 110880, the number 111,880, that's awfully close to 111,000 which on its own already looks mildly cool if you just truncate it at the 111K. But what even cooler is if you see behind the scenes when we get to 111111. Once again, that is a number that's more base dependent, but it is within a base one of the rep units, or as I call them, the hyper 11s. And numbers composed of just the digit 1 have a lot of fun properties. So we'll see, for example, how, well, I don't want to spoil it. We'll see more fun properties about the hyper 11 in our base composed of 6 1s, which will be passing in subscribers pretty soon, probably tomorrow, I'm guessing, because we've just been flying up recently, which is so awesome. In fact, we're really close to hitting 111,000 like now, like practically during this stream or right after. We're gonna get to 111,000, and so that last 111 won't have long to go. And in fact, if I end up ranting long enough, there's a chance we could get there in the stream tonight, but I doubt it because I'm probably going to wrap up this stream pretty soon. And tonight, after I wrap up our stream, I'm going to do some random note-taking on my computer about some fiction books I'm working on, as well as some fun episodes I'm planning for grade -2. A lot of good math topics coming, so for the math lovers, don't worry, the finale, well, let's say, put it this way, for the nature lovers and the chaos lovers, you're gonna love the finale. It's very outdoorsy, a lot of chaos, a lot of philosophy, and whether or not you like that stuff, please watch the finale episode. I'm putting a lot of effort into it. It's the first, like, movie-length thing I'm gonna have dropped, probably in my life, because I don't count the live streams as, like, the first, like, edited down movie length thing that I will drop in my life so far. So please watch that. It'll be on the main combo class channel. But for those who like the math stuff more, there's not as much math in it. It mentions a few math things here and there, but mostly it's about important stories from my life, important unseen footage and things like that, and cool new fun scenes that are more on the end of philosophy and stories and actions than on learning a math fact. But after we do that, and we do a little shorter intro episode for grade -2, which will be coming in early April, then I have tons of math episodes lined up that will be dropping on the main combo class channel, as well as I'm going to get back into making shorts on this channel, and I might try dropping some shorts on that other channel too for some extra rare shorts I have planned. I'll have to think about that, but I'll get back into making the shorts at some point soon too. But the main channel episodes, at least, will certainly have some really fun math stuff coming this grade. I already have more than a grade's worth of notes. We're already going to have to pick just the best, coolest topics out of what I have. So that'll be fun. And taking a peek at our comments, thank you to all of the thoughts. Someone's mentioning something about a take about a recommendation of reading an author or something about transcendental numbers. I will check that out. Thanks for the recommendation. And some other interesting thoughts about cutting diagonals from shapes and stuff. Yeah, so many different interesting corners of number and other things to explore. There also will be some more random science and language and stuff episodes coming out, because I do like doing other topics as well. A lot of the sciencey ones I've actually saved because I want to do them with actual visual representations of things that require weird technology or being in a weird place or things like that. So some of the science ones will have to come when I have the right circumstantial opportunity to use some type of science gear or whatever. Then we can get like an actual visual look at it. But I know for sure that I have more than enough math episodes ready for this grade, and then whenever we have the right opportunities, there will also be fun other snack breaks, science breaks, language breaks, and so on. I am going to wrap up our stream shortly, and to anyone who joined, thank you so much. And to anyone watching in the future, I thank you as well. I love all of you out there of my combo lords. All of the, almost hyper 11 amount of subscribers of you out there are super cool, but especially those of you who actually watch enough of this to tune in through the streams or through all of the main episodes or things like that. There's also my obligatory note that you should check out the Discord if you're not on there. A lot of cool chatting. That you should check out the Patreon. That if you have any extra budget in your life, very helpful for me and, in my opinion, for the world. The people supporting on there are getting thanked in the finale episode, which I've already filmed a whiteboard thanking all those people. But you can still support the Patreon if you want a bunch of cool bonus footage and to get your, to be thanked in some early part of grade -2. And also check out the subreddit, has some cool posts. And make sure, of course, you're tuned into the main channel too. This is just my Domotro channel, but there's the combo class channel that is just for the full best episode series. So make sure you're tuned into both of those. And I'm going to log off now. Leave any last thoughts in the comments. I will see you folks again probably tomorrow for some sort of Hyper 11-y celebration when we get to our Hyper 11. And or we might do that on the Monday morning stream. I'll have to see what my schedule looks like, as I'm doing mostly a lot of editing, and I'll be camping out in the classroom and editing a lot while I put together the hours of footage I have for that episode. And then the test answer videos will be coming this week as well, and more fun random stuff. So one other little note, let's remember that right now, if you write your dates in the form of month, then day, then year, which some places do, like where I'm from, that we are in a palindromic stretch. Right now it is 32523. Next will be 32623, then 32723. We are in a palindromic stretch of those right now. So 32523, that's not a bad one, pretty cool. 3 plus 2 is 5, so get a little addition symmetry. And can't wait to get going on grade -2. I almost showed you some other surprises, but didn't even want to show you the new lab coat yet. Some of that you're just going to have to wait and see, and it'll be very shortly, because by the time before March is done, I will have that documentary-like finale out. And by about a week into April, or within the first 2 weeks at least of April, I'll have started grade -2's episodes. I mean, in terms of release, I'm already working on being ready to start filming those. Just finished filming the finale today, apart from maybe some extra sequences and like a voiceover or two. I finished filming the final scenes today, which is why we are finally get to be more clean shaven and feel a little less awkward when I'm walking around town and I see someone look at me weird and I'm like, oh yeah, that's probably because I have half a beard. So, love you all. Thank you to all of the nice thoughts. And I'll see you again shortly. Hopefully I will get some random wildlife tonight, but whether or not I get any animal visitors, I know that in the morning the bird song will be really nice. Now, as for how cold it might get out here, it'll be mildly cold tonight. And to know exactly how cold it might end up being, maybe I'll have to check one of my new clock-like devices. One of the many things that I got for grade -2. That's telling me that right now it's about 50 degrees. And yes, that's Fahrenheit. I know the other system makes more sense at 0 to 101. This is once again what we use in the area I'm from. This is what I could find. Still looks pretty clock-like and tells you approximately what temperature it is in a not sure how accurate way because it's pretty cheap. That's pretty cool. So we got many new rarities for grade -2. I brought this one out to camp with because it'll be fun to see the temperature shrink a little bit during the night. And that's all the surprise you get to see for now. I will catch you all in the next one.